Welcome to Uni. What? Today you will start the chapter Light, Reflection and Refraction. Let's begin. Light. Light is a form of energy which induces the sensation of vision in our eyes and makes us able to see various things present in our surroundings. Units of light. Any object which has the ability to produce light energy on its own is called the source, denoted by the letter D. Source of light. Any object which has the ability to produce light energy on its own is called the source of light, e.g., sun, firefly, battery, cell candle, bulb, etc. Kinds of sources of light. There are two main kinds of sources of light. 1. Natural sources: these include all those sources which are natural and possess their own light, for example stars, fireflies, etc. 2. Artificial sources: these include all those sources which are man-made or artificial but possess the ability of emitting light, for example candles, lanterns, the moon, etc. Reflection. It is a phenomenon of light in which a ray of light from one medium strikes a smooth polished surface and returns back into the same medium. Laws of reflection. The two laws of reflection of light are: 1. The incident ray, the normal, and the reflected ray lie in the same plane. 2. The angle of incidence is equal to the angle of reflection of a ray of light striking a smooth polished surface, i.e., angle I equals angle R. Refraction. When a ray of light traveling in a homogeneous medium strikes a surface of separation between the two media, passes through it, and goes into the second medium, the phenomenon is referred to as refraction. Laws of refraction. The two laws of refraction of light are: the incident ray, the refracted ray, and the normal to the refracting surface at the point of incidence all lie in the same plane. The ratio of the sine of the angle of incidence of the sine of the angle of refraction is a constant for a given pair media, i.e., sin I/sin dot r equals constant. Refractive index. The refractive index of a medium is defined as the ratio of the velocity of light in a vacuum to the velocity of light in a medium, i.e., U equals velocity of light in a vacuum / velocity of light in a medium. Mirror. A mirror is a piece of glass having at least one polished surface and one reflecting surface. Spherical mirror. A spherical mirror is a mirror whose reflecting surface is a portion of a hollow sphere of glass. It is of two main types: concave mirror and convex mirror. 1. Concave mirror. A concave mirror is a spherical mirror in which the process of reflection takes place at the concave or curved surface as shown. 2. Convex mirror. A convex mirror is a spherical mirror in which the process of reflection takes place at the convex or bulging out surface as shown. Terms associated with spherical mirrors. The various terms associated with spherical mirrors are: 1. Center of curvature. The center of curvature of a spherical mirror is the central point of the hollow sphere of which the mirror is a part. 2. Radius of curvature. The radius of curvature of a spherical mirror is the radius of the hollow sphere of which the mirror is a part. In other words, it is the distance between the center of curvature and the pole of a mirror. It is represented by the letter R. 3. Pole. The pole of a spherical mirror is the center or middle point of a spherical mirror. It is represented by the letter P. 4. Principal axis. Principal axis of a spherical mirror is the line passing through the center of curvature and its pole. In other words, it is the line joining the pole and center of curvature of a mirror. 5. Secondary axis. Any straight line other than the principal axis passing through the center of a spherical mirror is referred to as the secondary axis. It is usually represented by the letters SS. 6. Aperture of a mirror. The aperture of a mirror is the portion of a mirror from which the reflection of light takes place. In other words, it is the maximum size of a mirror. It is usually represented by letters M1 and M2. Sign conventions for spherical mirrors. The various sign conventions employed for measuring distances in the case of spherical mirrors are: for the measurement of all the distances, the pole of the mirror is taken as the origin. All the distances measured in the same direction as that of light are taken as positive. For example, the focal length of a convex mirror is taken as positive. The object is placed on LHS. All the distances measured against the direction of incident light are taken as negative. For example, the focal length of a concave mirror is taken as negative. All the distances measured upward and perpendicular to the principal axis is taken as positive, i.e., the height of an object or image formed above principal axis. All the distances measured downward and perpendicular to the principal axis are taken as negative, i.e., the image of an object below principal axis. Optical image. If a beam of light emitted by an illuminated object suffers a change in direction due to reflection or refraction, the reflected or refracted rays of light converge or appear to diverge from another point. This second point is referred to as the optical image of the first point. The optical images formed by the spherical mirrors are of the following types. 1. Real image. Those images, which can be transferred or formed on a screen, are called real images. These images are formed by the actual intersection of reflected or refracted light rays. 2. Virtual images. Those images, which can be seen only by looking into a mirror but cannot be transferred or formed on a screen, are called virtual images. These images are formed by the apparent intersection of the reflected or refracted light rays. 3. Erect images. Those images, which lie or are formed above the principal axis, are referred to as erect images. 4. Inverted images. Those images, which lie or are formed below the principal axis, are referred to as inverted images. These images are upside down in appearance. 5. Magnified image. Those images, which are larger in size than the size of the object, is referred to as magnified images. 6. Diminished image. Those images, which are smaller in size than the size of the object, is referred to as magnified images. Terms associated with a convex mirror. The various terms associated with a convex mirror are: 1. Principal focus. The principal focus of a convex mirror is the point on its principal axis to which a beam of light rays, initially parallel and close to the axis, appears to diverge after being reflected from the mirror. A convex mirror has a virtual focus and lies always behind the mirror. It is represented by the letter F. 2. Focal length. The focal length of a convex mirror is the distance between its pole and principal focus. It is represented by the letter F and is always taken as positive. Rules for obtaining images on a convex mirror. The various rules employed for obtaining images on a convex mirror are: a ray of light parallel and close to the principal axis of a convex mirror appears to be coming from its focus after reflection from the mirror. A ray of light going towards the center of curvature of a convex mirror is reflected along its own path. Images formed by a convex mirror. The image formed by a convex mirror does not depend upon the position and size of the object. It always forms the image behind the mirror and in between the pole and the focus. The image formed is, however, always virtual, erect, and diminished as shown. Uses of a convex mirror. The important uses of the convex mirror are: it is used in rearview mirrors in motor vehicles to see traffic at the backside because it always produces an erect and diminished image of the object. It also has a very wide field of view, which helps a driver to have a clear view of the traffic behind. Terms associated with a concave mirror. The various terms associated with the concave mirror are: 1. Principal focus. The principal focus of a concave mirror is defined as the point on its principal axis to which all the incident rays parallel and close to the axis converge after reflection through the mirror. It is represented by the letter F and lies always in front of a concave mirror, thus a real focus. 2. Focal length. The focal length of a concave mirror is defined as the distance between the pole and principal focus of a concave mirror. It is represented by the letter F and is always taken as negative. Rules for image formation on a concave mirror. When an object is placed in front of a concave mirror, an image is formed at a point where at least two reflected rays intersect each other. The various rules employed for obtaining images on a concave mirror are: a ray of light parallel to the principal axis of a concave mirror passes through its principal focus after reflection from the mirror. A ray of light passing through the center of curvature of a concave mirror is reflected back along the same path. A ray of light passing through the focus of a concave becomes parallel to the principal axis after reflection from the mirror. Formation of images on a concave mirror. When an object is placed at different positions in front of a concave mirror, various types of images are formed, which can clearly be understood by considering the following situations. Object at infinity. When the object is placed at infinity from the concave mirror, the image formed is at the focus, highly diminished, real, and inverted as shown. An object beyond the center of curvature. When the object is placed beyond the center of curvature, the image formed is in between the focus and center of curvature. The image is smaller in size than the object, diminished, real, and inverted. object at the center of curvature when the object is placed at the center of curvature of a concave mirror. The image formed is also at the center of curvature, the same in size, real, and inverted as shown. The object between focus and center of curvature when the object is placed between the focus and center of curvature of a concave mirror, the image is formed beyond the center of curvature. The image formed is real, inverted, and magnified in the size of the object as shown. Object at focus when the object is placed at the focus of a concave mirror, the image formed is at infinity highly magnified, real, and inverted as shown. An object placed in between pole and focus when the object is placed in between the pole and principal focus of a concave mirror, the image is formed behind the mirror, the image formed is virtual, erect, and magnified, i.e., larger in size magnified, real, and inverted as shown. Uses of a concave mirror. The various uses of a concave mirror are: it is used as a shaving and dressing mirror. It is used as a reflector in car headlights, torches, table lamps, and searchlights, etc. The opticians concentrate light on the specific body parts during treatment. It is also used in solar heating devices to focus solar radiation, e.g., solar cookers. It is used as an object lens in telescopes. In the next class, we will start with the mirror formula and then learn about lenses. Subscribe for more. It's faster than the speed of light.